Okay, I think we can start. There's like 1 minute to go. So, good afternoon, everyone. My name is João Fernandes, and I'm here today to talk to you about GraphQL. This will be like a somehow fast-paced presentation. Actually, I wanted to ask something first. Is who has like played, just toyed around with GraphQL? Can you raise your hands? Okay, yeah. So my heuristic was good because I thought that most people haven't. So actually, this presentation is pretty basic, and I'm using GraphQL in a production environment somehow, and I have some more advanced things to share, like own experiences, but I'll probably leave those to like another presentation for another meetup here in Lisbon or something like that, because my expectation was that most people right now haven't toyed around with GraphQL. So what is it? So GraphQL is a data query language, and this is pretty much the art of saying nothing. But so we know data query languages. SQL, everyone knows SQL, right? Everyone has saw SQLs. Data query languages are used to fetch data from data sources. That's what they are used for. So this is like the hello world example in GraphQL. This is actually a query. You could like, if there's this magical server that is implementing this API, this is a valid GraphQL query. Essentially what we have here is that the server probably knows about this field called name that inside has this magical field called name. And if we would run this, we would get like this. So on the left, it looks like JSON. It's not JSON. GraphQL isn't JSON. But on the right, it is actually JSON. It's a valid JSON file. It's what you get. Like GraphQL server responses are JSON. Just to like stop the myth, there's always people asking me, and it's a valid, like it's something that happens a lot. Like people tend to think that GraphQL is somehow some sort of query language to query graph databases. It's not the case. Like graph is there because it models data as graphs, but somehow it has nothing to do with graph databases. So let's just remove that from the table. But let's rewind a little bit. Just wanted to kind of show you the hello world thing, but let's talk about like why. Why did Facebook come up with the need to do this and create this technology? And I'm actually going to not tell why Facebook come up with this technology, but I'm actually going to tell you about my own tale. So I was hired. I work for a small consulting company called Meta. We are based here in Lisbon, and I was hired to work on a new product. When I mean new, I mean like there was no line of code written before, like zero. So I was hired to start this from scratch, and this is like what new projects look like, right? I think it's actually Sandy Metz who once said in a talk that when you start a new project, it's like a beautiful garden, and it's your duty to keep it like this, because everyone knows that legacy code doesn't really look like this. Well, legacy code doesn't look like this because the world isn't perfect, life isn't perfect. So I was like, okay, now I'm gonna do this right. I have this kind of time budget. I'm gonna do this right. I'm gonna like write and build a REST API, and I'm not gonna be like the lazy guy, you know. Like I'm gonna be the guy who does it properly, you know. Like I'm gonna be the guy who thinks about like REST principles and implements an Premedia API, goes as far as that, because well, I'm sure that most people don't use Premedia because they are just lazy, you know. Like, actually, it's not the truth. Most people just like implement a subset of the REST principles into their APIs, because building using all principles is actually quite hard. And so like, but I began to like think about like the entities that I had to model and the relationship between those entities in the system that I was building. And I had accounts, I had users, so I was thinking, okay, I have to create endpoints for all these things. And I had products and customers, and then stores and store chains, and then emails, addresses, you know, like, and you start to think like these are not isolated. They like, I don't know, accounts have users have like, I don't know, have addresses and things like this. And you have to like build like a huge amount of endpoints, and you have to maintain this. And actually, like, not only, of course, that, like, the sheer amount of endpoints is something that by itself is hard to maintain. It's a lot of work up front, and it's hard to maintain. But also, like, I was looking at, I was giving a look at JSON API, the Premedia spec in specific, and I was playing a little bit around with the libraries to help me build representers for my entities. And what I ended up like realizing was that I had like libraries that would help me really help me like showing the data, but actually they are completely separated from the HTTP routing logic. And so I would have to maintain the HTTP routing logic and all the nuances that it has, because I would have to have like my domain / account / users / something, you know, like all that logic to come up with like the relationships between the entities would be on my side. Like nothing would do that for me. But there's actually more. Like there's more problems with somehow REST APIs, and actually here is more about like what Facebook felt. So GraphQL actually was born when Facebook started to like really turn to mobile. They really like, we are going to build like a mobile app of our thing, and we really need to consider mobile first. And what they was happening to them was that like the mobile experience was hard, because with REST APIs you are constantly simultaneously underfetching and overfetching data. So, and why is this? Because you are underfetching data because you need to perform multiple round trips typically to get exactly what you want. You might need like, okay, I want to know like the products that are owned, that like the user that created the given product. So you get like the account, you get the list of users. You get from the list of users, you get like products. From the product, you get like, I don't know. It's always like this. You end up performing like multiple round trips to actually get the data that you really wanted. And while this typically is acceptable on like good Ethernet connection, like really good wired connection at home, with mobile networks, you know, like if you consider just latency and the packet drops, things start to add up, and the experience is typically not that good. So on one side, you are underfetching data. On the other side, you are overfetching data, because among those requests, you actually fetched much more data than you actually wanted. You fetched the account. You probably fetched properties of the account that you didn't want. You fetched like maybe the age of the users, and you didn't want. It was there, but it was not something you'd care about. So we end up overfetching and getting lots of unnecessary data. And this, like in my experience, what this leads is to endpoint proliferation. In the best case scenario, you have a better API where these things are being passed as query parameters. Like you get the resource, you ask for a certain resource, and you pass the query parameter saying, oh, I want the compact representation that doesn't have like some set of given fields. But in the worst case scenario, like it really becomes like RPC style endpoints, you know, like get view with the customer or something like that. And this is the worst case scenario. And once you start having this, it's like, you know, like it's really, you go down the rabbit hole, because it's definitely no longer REST, like RPC style endpoints. I'm not like bashing on RPC. RPC is actually useful in some scenarios. People tend to run away from it, but it's useful in certain scenarios. But mixing the two is really the problem. You do either one or you do the other one. Another problem that derives from this is kind of cascading, is that you start to have backend and front-end coupling. Because, so what happens is, like a task that inherently seems to be just purely a front-end task, you give it to a front-ender, and at some point he's going to tell, you know, like the really good thing was like the compact view is almost perfect. We would have just to add some like 1 or 2 fields to it to get all the data that we need from in this view. And so the guy goes talk to the backend engineer, and you know, like so he's no longer able to perform the task like from back to back. He will have to talk to the backend engineer because he's probably not comfortable with that code base. And once you get like communication among people and among teams, you know, like development times like just go off the roof, and people is hard. Everyone knows this. And another thing is like documentation. So coming from the Ruby world, actually I believe that the best kind of documentation is no documentation. It's the best kind of documentation. Because documentation lies. Documentation keeps lying. Like I've had experiences where like I went to read the documentation of a given API, and it would say like either this field is an integer and I got like a number represented as a string. This field cannot be null, I got a null. This field is there, it isn't. It's not super common, like with high quality APIs. But the fact is it's there. There's nothing that really ties the documentation to the code. It's like they are two separate entities and they have their own life. So we do have a problem at hand, I think. And Facebook tried to tackle this. You know, are there solutions in the REST world for these problems? There are. Documentation, there's JSON schema, there's JSON API or like IP media specs and everything, but they are not like mandatory. They don't come as a package. And so people just like, I'm gonna do like the minimum for like what I need or something like that, and you start to have this you might get like spoiled by the really good API, and you go to another REST API and it's like, okay, do it yourself everything. So, okay, talking really briefly, just who am I? So my name is João Fernandes again. I'm a software engineer. I work like on the back end and I do some infrastructure work nowadays. Like I have no idea what is JavaScript. So I graduated from IST. And I'm a lead developer at Meta, a small consulting firm here in Lisbon, and I'm bootstrapping an internal product. And previously I was a team lead at Talkdesk, an R&D engineer at Corient, and I was also a research and project manager at Honeywell Aerospace in Czech Republic. My GitHub handle is JCM Fernandes. There's less public stuff than I would like, but I think it's pretty much like that with everyone. So what is it? What is GraphQL? This is round 2, right? So, okay, I'm sure you already got to know this. It's a data query language. So let's go a little bit deeper into what is a data, what I mean by it is a data query language. So I augmented the previous example that we had in a couple of slides before. And again, there's this magical field called me, and inside it has other magical fields. I'm assuming that like some server will get this and process this and will give me an answer. And the answer could be like this, you know? So essentially, like if you see like the data, the response mimics the request. You see, like it's very visible from here that essentially it's like we are asking for keys and pretty much getting the keys with the values. It looks pretty much like that. So let's augment this a little bit further. Let's say that I wanted to know like the country where I live in. And okay, so it's saying that I asked for address, and inside of the address there's like a field called country, and somehow it knows that it is in Portugal. But typically when you get like these query APIs, you want to restrict the results. For instance, you might want to know just the users that were created. You might want like, okay, give me the users, but just the ones that were created like in the last 2 days. Or just the ones that, you know, like filtering down. You want to pass data to the server to filter down those queries. So what if I wanted to know where I was living 4 years ago? Okay, so GraphQL also has means for that. So I would have like what is called an input field in the address, and I'm passing like a string saying 4 years ago, the parameter is called when. Somehow the server handles this. Of course, it's our logic, it's not magic. But somehow it will take this and we are passing data to it and adding constraints to our query. So properties of GraphQL. First, it is hierarchical. And like in my experience, most domains that I end up modeling are hierarchical. You have, again, accounts have users have, I don't know, tasks, if it's like a to-do list or something like that, and they might have like friends, and friends also have tasks or something like that. Data is typically inherently hierarchical, and it has relationships. It's client-driven in the sense that the client it tells the server exactly what it wants to know. I want to know like the name, so I write the name. If I don't want to if I don't want the name, I erase the name from the query. And also, you get what you want, no more, no less. And there's like no custom endpoint here. Like actually, with GraphQL APIs, you get just to do one endpoint. Typically, it's like domain/GraphQL, and that's kind of the practice, the normal practice, and that's it. It's the only endpoint that is used for the server. It is structured in the sense that, as I just said, if you notice that the request and the response, they look alike. Like it's very similar. So there's a structure. The server has to model the response in a kind of a structure that is defined by the client itself. But this structure doesn't impose like much on the code below. Like the code below has to be able to build this structure somehow. But it is arbitrary code. It's our code. It's kind of a layer. It's like a transport layer or application protocol on top of our code. It's transport agnostic. So most people will end up using HTTP, but there's nothing that ties GraphQL to HTTP. It is strongly typed. Like as a Rubyist, I'm a dynamic typing guy. But GraphQL is not a programming language. It is a data query language. And like the only way to be able to build schemas for data, like really good schemas, is knowing the types of the data. And so schemas are for data, pretty much what tests are for code. So they don't lie. If a schema says that there's this set of fields with these types, it is there, unless you got the wrong schema, but then there's nothing much you can do. But like if the schema says that, it's going to be true. And it's introspective. So in the sense that you get this schema, and you can introspect it. You can introspect the type system, and with this you can like do really cool stuff. You can do like dynamic code generation. You can do like auto completion in IDEs because you know the schema. You know like this object has this set of fields, and these sets of fields are of this type, and they take these input parameters and everything. You can do things that actually enhance the developer experience. So let's go. I know it's a lot to process, but I'm going to show you a little bit more like how queries what are queries made of in GraphQL. And GraphQL is not a very extensive language. It isn't. It only has these elements. And I'm not going to talk about mutations. There's really good sources on the web. Mutations are what allows you to modify the system. So I'm going to just talk about like the fetching part, just the querying part. So again, actually, like the only small change in these slides here in the beginning of this query is that I named the query. It's optional when you have just one query, but it's a good practice to do so, like to write query and give a name to the query, awesome query in this case. And documents GraphQL documents can contain multiple queries and mutations, other things that we'll be talking in a little bit. And that's like a GraphQL document. It's a collection of GraphQL things. And then you have fields. All these things here, me, name, age, programming language, and versions, are fields. They have types. Some are like primitive types, like for instance, I assume name is a string. I assume age is probably an integer. And this programming language is like a custom type that is not a primitive type, is a custom type that I define, and that inside has name and versions fields. So we already saw this example that I passed, like I want to know like where I was living 4 years ago. But what if I wanted to actually let the client, the guy like on the browser, insert data here, like into this query? Well, the naive solution would be to do like string interpolation. You know, like I would go here and replace. I would put something there and replace it, kind of template-based thing in runtime. But actually, GraphQL is more powerful means to this task. So you can declare variables, and you can declare the types of these variables. So first of all, types are going to be checked. They are going to be checked about non-null, if they are null or non-null. It also, like, if you declare a variable, you don't use it, the client will tell you right away you are declaring a variable that it's not in use. So it's more powerful than just like having like string interpolation. It gives you more things. And what if I wanted to get some of this data just like conditionally? So imagine that there's like a variable here that in some cases, based on the checkbox, for instance, maybe I want to get the address, maybe I don't want to get the address back from the server. So this is where, for instance, directives enter. And actually, directives are not used just for the example that I gave you. Directives are a little bit more powerful. They interfere in the query resolution. There are more directives. There's include. So include here is I think it's pretty obvious to understand. That's like there's this new variable there, show address, and if show address is true, then the address should come. If not, then the result would not include the country. But there's other directives. There's like skip, which is pretty much the inverse of include. And there's more things now like that the Facebook is experimenting with. We'll be talking about them in a little bit. So let's go back to like the simple example that I gave you. So imagine that you already have your views coded, your components, and somehow along the way you close the pull request and you were expecting that this programming languages thing, like this string was actually just languages, was not programming languages. You know, like, okay, now I have to open a pull request or something like that. No, I don't. I can just make an alias. So I can just say, okay, give me this back as languages, and in the answer you will get languages. Sometimes this is like optional in these scenarios. Like you can just, it helps you model the request, the response with your request. Sometimes it's actually mandatory because sometimes you need to disambiguate when you have like, you are fetching for the same field with different input parameters. So let's move and think that actually I want to, so I have friends, like software engineers have friends as well. We also need them, need a hug sometimes. And but unfortunately, it seems like all my friends also do like programming. It's a very narrow set of people. And immediately when you look at this query, you see right away that there's like duplication here. So essentially, I'm using like the programming languages block is exactly the same for both me and my friends. So we can use fragments to deal with this. So fragments are essentially what enable us to like do string composition. You can extract things from the query and create fragments that are going to be used a lot, or you expect to be used a lot, and you can like compose strings. So essentially, it's like you inlined that piece of code there. It's exactly the same. These two queries are equivalent, and that's it. With queries, if from a front-end developer perspective, I really covered, like besides mutations, I really covered all the kind of things that the language gives you to perform queries on a GraphQL server. I took like what, 5 minutes top. It's really, really small language till now. Now I'm gonna try to like make backenders a little bit more happier and talk about like how to define the schemas, how to create the schemas. And I'm going to do this in Ruby. So schemas are composed of just these things: objects, enums, unions, interfaces, and input objects. I think that like for any programming object-oriented programmer, maybe input objects is the only name that is not immediately somehow obvious, because pretty much I think that all the other ones, for those who know Java or like C, they will be what you are pretty much expecting. So this is an example of declaring a user, a type, a user. So I'm saying that a user, I'm giving it a name there, saying user. User type is just like the constant I'm using in my Ruby code to get the reference for this type definition. And I'm saying, okay, I'm creating a type. The type is called user. The description is just like whatever you want. It's just documentation. You can write whatever you want. And then I'm stating the list of fields that this type has. So it has an ID, and it has ID is the type ID, and I'm adding some description. The exclamation mark is to say that the type cannot be null. If it has no exclamation type, you can get a null value as a response. If it has, you can't. And like the only thing that is not so obvious is like the last one. I'm saying that this user belongs to an account, has an account object, and you see their account type, which is like a type that I created somewhere else in my application. Enums, not much to talk about it. It's just like pretty much what you are expecting. I shamelessly copied this example from the Ruby GraphQL gem. I didn't have my own example, but it's pretty much what you would expect to see. You name things and they get like values. Unions are pretty much what you would expect to see in somehow C. It's like imagine you have a field called contact. And a contact might be either an address or an email or a phone number or like GPS positions or something like that. And you are essentially, when you're declaring that a certain field is of a union type, you can expect to get one of the types of the union there when you get like that field. Interfaces are just a way to compose. It's like pretty much like protocols, right? It's just a way to compose the schemas. So if I look at the user type example that I just showed you before, essentially if I'm saying that now user type implements the interface created and updated timestamps interface, I'm saying that it now has to also answer to both these fields, the created at and the updated at. Just as simple as that. And an input object too is just like the only one that is not completely obvious right away is the example when I showed you I had the when parameter too, and I wrote like 4 years ago there. So inputs to my query. So those inputs are also an object. And actually the gem for Ruby, it creates the input objects like on the fly. You don't really have to do it. But you have just to say that a field has like an argument. In this case, I'm saying that it have an argument ID. So you have to pass the ID, and then I would get the ID here on this args variable, and I would access the ID there. As simple as that. Done. And now I'm going to attempt a live demo, so beware because things can go like spectacularly wrong, right? As always with live demos. So let me just check. Yeah, okay. So I did a really small example. I'm going to reduce expectations in the sense that there's not going to be a wow factor. I expect you just to realize how like quickly I ended up like showing you this. So really small Ruby application. I created a web server, and I added just like it answers to posts on the GraphQL endpoint, and just like does some body manipulation and converts things to JSON, and that's pretty much it. And like the important part is where you see on line 8, you see that I'm declaring this constant called GraphQL Schema, and I'm saying, okay, this is a GraphQL, and the root of this query is somehow in the modules, is somehow schema query root. It's somewhere else. You don't really need to know much about this. I'm parsing some JSON, and then I'm putting it inside the GraphQL schema there on line 24, and also variables, and that's it. But you see that on line 6, I'm including the schema. And schema is this file for now. I just added some really small boilerplate here, so we don't have to do everything from scratch. But this doesn't really work right now. So I'm going to have to implement this. I referenced this constant there, right? It's the query root. Something has to be written there. And that's what we are going to do. And on the first line of this file, you see that I required another file called data. And for this example, I'm going to show you I'm going to imagine that I have like this in-memory just set of relationships between manufacturers, cars, and engines. So a manufacturer has multiple cars on sale, and the car has an engine. And there's like fields. I'm seeing people like smiling because everyone knows I love cars. So let's do this. So by the end of this, just like the important part of this file is just to realize that I added a hash there that is called manufacturers on line 57, and I'm saying if it's Porsche, it points to the object that I created there called Porsche. If it's Ferrari, then it points to the object that I created for Ferrari. That's it. going to do the schema. Okay, so I'm going to add a field called manufacturer. So first of all, I'm going to introduce you really quickly to this. This is GraphQL. It's a tool that is made by Facebook, and essentially it allows you to to execute queries. It's like the autocomplete IDE I was talking about for queries. It already exists somehow, and you can even navigate for like documentation. Well, but there's really nothing there right now, right? So there's nothing really running there. I think this probably crashed because there's nothing there. Let's continue. So I'm gonna, first of all, I'm gonna have to like implement something like manufacturer type, and I'm going to have to create a new type. So I'm saying that I have, at the root of my query, I will have a field called manufacturers. That's it. And so I have to create what is a manufacturer. So I'll have to give it a name. I'm going to skip the description. I could like just add a field called description and write something, and we'll say, I'm actually going to write it just like, so we can see like, manufacturer, woohoo, super cool. And now I'm going to like add fields to it. So I saw that, where is it? It's here. So seems like I said that manufacturers only have a name and like a set of cars. I'm expecting an array here. So I'm going to say that I have a field, what is it? This name, exactly. It's from types string. And I'm going to skip documentation. And it has like a field like called cars. And it's of types, well, now is where you get, okay, so I'm saying that cars is an array. So I'm going to say that this is an array. So something like this, and car type. Well, I have to create car type. I have to say what is a car in the end of the day, by the end of the day. But let's just comment this and try to like, does this run right now? Okay. Oh, sorry, I have to manufacture type. Well, I have to, okay, so there must be something here on the docs. No? Okay. Just a second. Oh, okay. So, query. Okay, so, oh, it already shows that I have a type called manufacturer here. Right? So I could, it's an input object, so it's an input field. We declare that we have to pass something for it to be able to work. So I said I have to pass the name, and I'm going to say like Ferrari. Okay, so this has things inside. Okay, it has a name. So will this run? Well, no, not really. Why? Because actually I didn't say how to resolve that thing. I never said where is the data. Right? I never wrote that. I modeled a little bit of the domain, but I never said how do we fetch the data. And this is where we have to do it. So I told you that on the data file I had this variable here, right? So I'm just going to like do this. So it's an hash. So it could just like do args and and name. This should work. I'm saying like args has like the parameters that were passed as an input. And this it's just an hash. So this must work. Let's see. It does. Array. Super cool. Huge wow factor, right? I know, like backend people are like, woohoo, this works and everything. Then you see like graphics and everything. So it's really hard to be a backend engineer. My boss never gets excited about these things, you know, I don't know why. So let's continue with our example now. So essentially I said there's like a field called cars, right? So I'll also have to declare this cars type. So car type, that's what I said it was. So it's like GraphQL, object type, dot define. So it is like the name of the type is car, if I would write it correctly. And then, well, what does it have? What does it have? It's like, okay, it has a model and an engine. Okay, so model is a string. I'm expecting it to be a string. I know it is a string, right? So I would go here and do this string. So actually, if we run this, okay, should work. I have to somehow reload the schema here. Okay, I wanted to show you this because we can navigate like across the documentation that was generated. So it is telling me that there's a root type called query. That root type has like a manufacture field of type manufacture. And we already see here, so it has a field called name that is non-nullable and cars that is like an array of things of the car type. So it's already telling me much. So this should already work here. Cars, sorry, wait. And model. So those were the things that we did here, right? So those were I just modeled this bit. So does this work? It does. It already tells me like, whoa, whoa factor again. It tells me, well, I could proceed with this example. I'm running a little bit out of time. But this is just like, the idea was just to show you like, I did like objects to model part of my domain in like 5 minutes, something like that. That was the amount of time we spent doing this. Like we would just have to continue cover the things, like create types, GraphQL types to represent the types in our domain. Like this magic kind of works. Like one thing that I didn't really say was that when I declare this thing, this field called name and this field called cars, it is expecting that the types that are the Ruby types that are being passed implement methods with the exact same name. It's expecting to have like that manufacturer as a method called name and as a method called cars, and this is how it does, like it glues things together. You don't really have to write the bindings manually because it does it by how is it called? By convention. Sorry. All right, missing the word. So where is my flew away? Oh, that's it. No. Okay, I'm gonna end it like that. Doesn't really matter. Okay, tooling. So I already showed you GraphQL. That's the editor we just used. Oh, sorry a little bit. And there's already a couple of JavaScript clients to help you interact with GraphQL servers. Relay is the most popular. It's the one that was created and it is developed and backed by Facebook themselves. The other ones are backed by other companies or just like community backed by one guy somewhere in the planet. And they will help you somehow answer questions like, how do I maintain cache coherency? How do I maintain a cache? How do I maintain it coherent? Relay also implements its own spec for pagination. You have to implement cursor-based pagination. It really requires that paginated fields are implement a given spec. It is not super hard to make a GraphQL API relay compatible. It's fairly straightforward and documentation is really good, at least when using the Ruby gem. And there's already like several GraphQL implementations, server-side implementations in several languages. I'm using the Ruby one. The one I didn't include here is the reference one. The JavaScript one is the reference one made by Facebook. All the other ones are community-based. But there's Ruby, PHP, Java, .NET, Sangria, Easy Scala, Go, Elixir, and Haskell. And I think there's actually more by now. So we are almost there. And this is like the part of the talk where I would probably create other presentations about my own experience, about things that like pitfalls that I got into when developing this and learning about GraphQL. There's a couple of questions we have to ask, and you have to ask yourselves if you should use it. So first one I think is maturity. Like, how mature is this? Like, when we are doing code in production, if it's just a toy, then maturity is not really a question. But when we are talking about production code, then maturity is a question. So GraphQL is the language, right? The tooling, like the graph, it obeys to a spec. Then the tooling, like mileage might vary a little bit because JavaScript is the reference implementation. It's backed by Facebook, and it was open sourced last year, but they are using GraphQL internally since 2012. So gazillions of requests have been served using GraphQL. But mileage might vary when using, like, not a long time ago, I had a colleague, he was doing some code in Java, and he was looking around the Java server-side implementation, and they were, for instance, it looked mature, but they were looking for maintainers, and they were like, okay, we are low on maintainers, and they were asking for maintainers. So when dealing with the other implementations, I would recommend you to kind of fill the thing first. Then stack fit. How does this fit into your technology stack? And I know that the JavaScript world is a fairly complicated world. So on the front end, you have to, like, I don't want even to hear or be near it because I hear nightmares about it. But you have to think, what if, for instance, React only works with Relay only works with React. The other clients are not really tied to a framework. But you know, it can be more tricky with one framework than with the other. You really have to evaluate the fit into your client-side stack. I think that's more like on the client side than on the backend side. Because on the backend side, we are going to talk, I think it's more important to talk about architectural fit. And one thing that GraphQL, it's fairly obvious. It was not super obvious to me, like when I just heard about it in the first presentation that I saw on YouTube, but is that GraphQL pushes you and forces you to get into a API gateway kind of architecture. You cannot have like a service called users.mydomain.com and have another service running on, I don't know, products.mydomain.com and have like different web stacks and everything, like being them completely separate servers. You have a single endpoint, and that single endpoint has to be able to like deal with the relationships among data. You have one schema. So this inherently pushes you and forces you into this kind of API gateway style where you have one component, either it's kind of a monolith and it's all together, or you have like a more microservice architecture where you have this thing, this gateway, then interacting with the other set of services you have in the backend. This is pretty much how I ended up doing it. I have a gateway and I do RPC calls to the set of services that I have running, the set of microservices that I have running. Another aspect is best practices, or somehow, or more important, the lack of some best practices. You know, I think that there's some unanswered questions around the, like, what are the best practices? And to me, like, the most obvious example when I started to deal with this was errors. So how do I transmit errors to the customer? You know, so I have to give this JSON payload. So if I failed to like fetch the data from one of my microservices, how do I convey that information? Worst is that, so if I have like a set of microservices in my backend, imagine that I had like some service that to fetch URLs for images and some service to fetch names of products, something like that. Well, then, like, if you like listing the images without the products is probably strange. I don't know, but listing the names of the products without the images, imagine that your images server goes down. You don't want, you probably want to degrade gracefully. You don't want to, oh no, one of the services, one of the pieces of data that you requested is down, you cannot get any data. So, and actually there's, unexpectedly, at least to me, there still isn't a set of best practices to convey this and to transmit this, how errors to the applications. And there's also another aspect, I don't have to deal with it, but my colleagues, my front-end developer colleagues, keep telling me about this, and I get their point, is that when we are defining mutations, which we didn't do here, but mutations is what you use to say, like, change this, I have this object, change this object, or create this object, or delete this object. Actually, when you imagine that you have a blog where you have like posts, if you create a post, okay, I get a new object representing that post. But there might be side effects on the creation of that post. For instance, I might have another field called posts count somewhere else. And I know that posts count will change. I added the post. But essentially, like, the way Relay works, and I'm specifically talking about Relay works, is that you have to know these side effects. You have to know that you have to like delete the cache, your local cache for posts count because you created a new post. This information is not being conveyed in the schema, so it's error prone. And future. So where is this going? Well, GraphQL is backed by Facebook. So, well, I don't see it going, like, disappearing anytime soon. And so that thing, I think it's right. It's a non-issue, to be honest, right now. I think that it's more important is to see what new functionalities are being added to this. For instance, one thing that you might have noticed, or like, is that to give an answer, like when someone makes a query, you actually have to send the whole answer like in one piece. And that's depending how much time it takes to actually like do all the fetching of your backend services. It might take a long time. And also like reactive updates. You know, like for instance, the example on Facebook is that right now you see things in live when people write new comments, when they liked, it updates like the like count when you do this. So they are experimenting with new directives. If you remember the include directive. They are experimenting with subscriptions, with streaming, with defer, which is like, I'm saying that this is not really important. Send me as a JSON patch later. I don't really, give me just like the response in chunks, and I will try to, and you can even say what is more like, more important to you, like to show first and try to enhance the user experience as much as you can with these directives. Well, Meta is always welcoming bright minds, and I'll be thrilled to talk to you a little bit more. So find us at metaicg.com. And that's it. Obrigado. So questions? Vasquez.
Wait, we have a microphone.
Thank you. Thank you.
Awesome. Hi, I'm João, also. I have a couple of questions, but I'll probably start with the last one I wrote. How does GraphQL stands for schema evolutions and deprecations? Because Facebook, I bet they have lots of versions of their schemas and stuff.
Yeah. So really good question. Actually, it's one of the aspects that Facebook, like most GraphQL presentations touch, is like versioning somehow, like it's schema evolution. The reason why I haven't touched it here is because I don't have much experience to back their claims, to be honest. Like their claims make sense, but since I have not explored that much, I have left that aside. But to give you their answer is like, you can always, what they do is they pretty much they add new fields. Like since you don't have to, unless you remove things, that's when you break stuff, right? Unless you keep adding stuff, you essentially have like no break. You just like, the schema now has a new, you enhance your schema with a new field, okay, now you have a new field, you can query more data, you can query that field. If you change, I think it's like every public API. When I mean public API, it's like object public API. So if you change things, you'll be dealing with like breaking stuff. And this is why the reason, because it's also a little bit confusing to me, because sure, of course you can like, you have a function or a field that has some input queries, and it was like, I don't know, get contact or something like that. And if you change the names of the things for some reason, or if like the representation of the object really goes far away from what it was previously, then I actually don't see much of a solution unless they create like a totally different representation, a different type to represent that entity. They make claims about this. I honestly haven't felt like it's much better. So I haven't, but sorry, it's a really good question. I just haven't experienced the pain, so I have no good advice to tell you in this moment. But more questions? Yeah. Should.
How do you compare your experience using Premedia APIs versus GraphQL? Pros and cons of each.
Yeah. So I think that touches the part where. So most people take Premedia as a non-mandatory thing. Let's put it like this first, right? So most REST APIs you'll find on the web, they are not Premedia API. They do not convey navigation and metadata. So my own experience is that if I wanted to do exactly what I did for the example that I showed you here, using, for instance, JSON API, we would have to do much more code, much more boilerplate, because you have to. So my experience with those things is more about with the tools than with the spec itself, not about consuming, but about generating the data. And GraphQL has this really good thing where you don't really take care of the representation, and you don't take routes and representation are somehow mixed together. You give it an object that answers those sets of fields as those methods, and it's done. You don't really have to care about how things are shown in your response. But with Premedia APIs, at least to my experience, you do. On one hand, you have to create DAOs, data access objects, representers to your entities in your model. But on the other one hand, you have to maintain your HTTP routing logic separate from, and that one is you are alone, you are going rogue. Now it's your duty to maintain if the guy goes for /accounts, you give the accounts, but if he goes for /accounts/users, then it's your duty to route that thing properly. Accounts, users, something products, you are on your own there. So I really like the fact that GraphQL intertwines these two concepts, representation and routing. So to my experience, at least, I felt much less pain when doing this. I'm not saying that the existing solutions don't work. And that's I cannot get on this stage and say, forget everything. This is going to save the world, the world was doomed and there was no salvation for it. The tools existed, but they did not form a package. So people there's too much freedom. It's we need Linus, a benevolent dictator that would tell you what to do. More questions?
Do you know of any middleware that can translate GraphQL queries into database queries and return back to the client?
There is. Actually, good that you asked that. Immediately after you asked that, I remembered that I forgot to add one thing here. Sorry. In this exact slide. There's a PostgreSQL wrapper that essentially you just mount it and say the database is here, and it pretty much deals with authentication and everything more. So this is to answer your question. The answer is yes. You can pretty much mount this on top of a database directly and rely on PostgreSQL capabilities for authentication. I didn't even know that they had it before, but Postgre does everything, 20 years or something like that more. So you can mount on top of that. But even to augment my answer, there's actually companies nowadays that the only thing that they are selling is GraphQL APIs, So you go, you buy, you define your types, and they take care of the storage. It's like API as a service. This exists. I think one is called Reindex, I think it's Reindex, I think, or something like that. Sorry. Is that it? You will have a question. Okay, thanks everyone.